So this is a biometric attendance system that uses a Raspberry Pi and R307 fingerprint sensor and a Pi camera, and it integrates all of these components together to form a complete attendance system. And it comes with a client side mobile app and desktop app, and it has a server that is running on the Raspberry Pi. This is a 3D printed box that I printed out for this project, and yeah, so it works like this. So right now there are three options for us to choose from. One is display IP. So when you select that option, it will display the local IP of the Raspberry Pi server, and that local IP you need to enter it into this text field on the mobile app to connect to it. And after you enter the local IP, this connect button will become enabled, and then you will have to press it to connect with the device. So yeah, right now these many students, their names are in the database, and the fingerprint icon is like errored or something because their biometric details are not enrolled right now. Only my data is recorded right now. So yeah, when you select any of the two options, that is attendance and bulk attendance, it will trigger a loop. Will fire the sensors continuously and try to detect if someone is there. So it found my fingerprint, and it displayed my details at the display, and then it will be logged in this internal log here. Here, as you can see, at 12:47 p.m. I entered the classroom, and then if I want to get out of the classroom, I will um, fire up the system once again and put my same finger or my face. Also, it's dark right now, so I am not using my face, and as you can see, there is one another log here that shows that I got out of the classroom at 12:47. Now I have enrolled my thumb as a teacher. There is a separate section for teachers enrollment, and yeah, so when I enroll myself as a teacher, then here it shows that teacher 1 entered the classroom at this time, and using the same logic I can also mark when I get out of the classroom. All of this data is then grouped into classes. So this is a data science class that happened from this time to this time, and the number of students that were present is this. These are the entire logs that were captured on this particular date. You can select any date from here, and I will work on a feature to export these dates to another format like a spreadsheet or something. Then you can tap on a log to delete it maybe, and you can view the sessions also. Here there is also a date picker to select any date that you want to, and yeah. So I got handed over this project from my college. Previously, it was being worked upon by a senior, and they honestly did nothing. Suddenly, I got the opportunity to work with Raspberry Pi. This was 2 years ago, and I was very enthusiastic about Linux, and I was just exploring stuff. I was using Fedora at that time, and suddenly I got the chance to use Raspberry Pi. And the only thing that I knew about Raspberry Pis at that time is that they ran Linux, and because of that I wanted to learn more about Raspberry Pi, because at that time it was hard to get one Raspberry Pi, and it was like 8,000 rupees, which is like $100, and I was just a student, and I couldn't afford that. So I decided to work on this project. I managed to hack together a simple script that runs attendance logic and stores stuff in a simple CSV file. Student info in a CSV file. It only supported fingerprint scanner, and this was that project. And this is a simple collection of scripts, and this was the beginning point when I started hating Python passionately. Like, Python sucks, terrible language. So yeah, so it was using sync thing, and I was introduced to concepts like VNC, cron tab, py fingerprint module, which is a Python module, which is a wrapper around the py fingerprint, around the native firmware of this fingerprint module, R307 fingerprint module. Then there is this Luma code library, which I'm guessing was the library for the previous display that I was using. And yeah, I fleshed out all the detailed steps on how to replicate this, and this was the model that I finalized on. It's very hacked together, very rudimentary. Everything is held together by tape. And yeah, this was the first model. And with this, I managed to win two competitions in my college, one outside the college and one in my college. And yeah, it was a pretty good good time. I don't know what to call it because as far as I knew, I only hacked together what was available with these technologies, with Python and Linux, all that. I only hacked together stuff to build this. So I didn't innovate anything new. I didn't get the satisfaction of building something new, something that I could be proud of. And people were treating me like I have done a very big thing. Yeah, so it was like I don't deserve this. It was like imposter syndrome plus. And yeah, so that was an experience. So after that, my college professor told me to integrate a camera with this. Uh, so he wanted like a simple, he wanted a full-fledged system that also had a camera with face detection, and it ran the camera and the fingerprint detection simultaneously, and tried to detect whatever student or teacher was entering the class. And despite hating Python, I decided to work on it because it was a Raspberry Pi and it was an excuse to bring this device home. Tried to implement face recognition with this library, with a previous library. I forgot the name. It was OpenCV or something. But it was okay, but it had way too many inconsistencies. It was like detecting one person for another. And because of all that issues, I decided to use dlib, and it has been pretty great so far. I don't know how it works. It takes some pictures, then makes a encoding or something, stores it in a pickle file, and when it starts to detect faces, it goes through all the stored pickle files and um, figures out which one has the closest match. Facial embedding or something. I don't want to get too deep into those stuff because I frankly don't have any interest in that. I'm just using the library as an interface to build this project. That was pretty good, but the problem was that the professor wanted something very complicated, like it wanted something that can be controlled easily, and he wanted to change the database schema again and again. Like he wanted to add some other parameter and some other new form of time measuring something. So I decided to rewrite everything, and with my favorite language, that is Kotlin, I decided to rewrite everything and make it robust and something that I can be proud of, because anything that is related to my name, anything that has my name in it, I want it to be perfect, and I will not tolerate it to be less than perfect, because it's just my insecurity or something. But anything that I am involved with, I want it to be the best. So I decided to rewrite everything in Kotlin. It still has some Python things here, and this is the final result. And yeah, so let me go through the code. This is the code base and the readme file. Let me start with the sensor server. So my old Python code, it was very buggy. It had many runtime exceptions, many runtime issues, and it was very hard to work with because there is no decent Python IDE for Raspberry Pi that is fast enough. And then all the IDEs that I wanted to use, like PyCharm, they were paywalled to have that SSH feature. So I decided to use as little Python code as possible, because all this interface libraries like this PyCamera library and the fingerprint library, PyFingerprint library, these are Python only libraries. These have C++, these are essentially C++ library wrappers, but I didn't want to get on write whole C++ modules by myself. So I decided to use as little Python as possible, thoroughly tested it. Everything here is tested. Every state here is tested if I am correct. And yeah, this should not crash at runtime. If something is missing, it will just print that something is missing and then exit. This program is battle tested, and I am confident that all of this Python code here, this code will never break, unless one of the libraries that I'm using, they break inside themselves. That's another issue. But the code that here, this code, this has a very low chance of breaking. I've commented everything out with docs and some unnecessary jargon and some test on the files itself. This is not structured like a typical Python project because I hate Python. I don't respect Python. And yeah, the every file, the name of the file will tell you what the file does. This keypad.py, this has all the stuff related to reading the keypad, and this face capture.py has all the classes and functions related to capturing faces. And yeah, pretty self-explanatory. Then there is the cron job.sh. This is a simple script that I can pop up into the cron job, and cron job will execute the script. I tried to put these commands themselves in the cron job file, but it wasn't working for some reason. So I decided to wrap it inside a script and then run it using cron job. I'm using UV, by the way. Makes Python so much simpler. Like if UV didn't exist, I think Python would be dead by now. And then this is all the sensor server stuff. The sensor server, its only job is to interface with the sensors, and it stores no database, nothing, and it has a simple API that is exposed using Fast API. And yeah, using Fast API, I'm putting all or exposing all the functions that it has, and I'm hosting that in port 8000 or something. Yeah, port 8000 localhost. So in the local network, this server will be available. And then the Kotlin part. So Kotlin has an LLVM backed native compiler that mostly iOS people use that for compiling it to iOS native, but it can also be used to compile stuff down to Linux native and other platform like Linux ARM 64, which is the Raspberry Pi. Raspberry Pi is ARM 64, and this operating system is Debian Bookworm 64-bit. So for ARM 64, I wrote a different module. First of all, I decided to write a core module that will be shared with the client app and the server. These are the platforms that it supports. Like here is Linux ARM 64, Linux x64. I don't know why I kept that. Then there is the JVM, which is the desktop one. Then there is the Android library. While I was building this, Gradle 9 came out, and it introduced significant changes in how you want to structure your Kotlin multi-platform project. And it was an experience dealing with all the bugs and jargon that Gradle 9 put on. At the end, I think all the changes that Gradle 9 introduced, like separating modules into platform specific modules and having a single module for all the core logic, I think it's better actually. Previously, you kept all of the build logic of the apps in the single module, but I thought it was getting messy, but now you need to keep build logic separately. For the Android app, I have Android app module, which imports this core module and this client module, which I will come on to later, and it just builds the app and just packages it. Similarly, there is the desktop app module, which does the same thing, but for desktop JVM platform. Yeah. So the core module has some models and interfaces that was needed to build this app. And yeah, so there's this attendance log model, there is the teacher model, there's the student model, and entity type, detailed attendance log, which is simply an interface to uh, to perform complex calculations in my apps. And then there is the admin interface. I'm using Kotlin X RPC here. So Kotlin X RPC gives you the whole infrastructure of just passing on the interface implementation over a network with the help of WebSockets. And it's Ktor based, and the Kotlin X serialization JSON. And with the help of those, I think it has made application development way easier. I can just uh, I can just build an I can just implement this interface somewhere in the server and just pop it up in the Ktor client side logic. And in my client app, I will have access to the implementation of this interface. Like it was no big deal. So yeah, no REST API, nothing, just simple interface, Kotlin interface that is transported via network and WebSockets. So yeah, and there are the common error methods, common HTTP methods that I use in all my apps. This is the core module. And then there is the server module. The server module is only supported for Linux x64, Linux ARM64, and the core module was a bit tricky. So I faced a lot of issues. The HTTP client. So Kotlin is not targeting native platforms right now. So they are currently building Kotlin multi-platform for as many platforms as they can. I guess that is what they are doing. And it was pretty trivial to figure out all of the quirks of a native platform. I wrote all the code here. I'm using Room database in the server, which is very unusual for a server app. A server app usually uses something like its own SQLite facade, but I'm using Room because it is the thing that I'm most familiar with, and it happens to work on Linux ARM64. No problems at all. It creates a server database. The only bad drawback that I faced with Room is that I still haven't figured out a reliable method to declare where the server should be created. The server database file is created by default on the home directory, and I think that's fine. I have no complaints about it, but it would be better if I could choose where the database file is created, and the Kotlin X file operations that are available in ARM64, they are not enough to declare that stuff. Yes, so that's the only issue that I faced with the Room database. And I'm instantiating a Room database here. Here it is, the Room database. There are entities, there are teacher entity, then there's the attendance log entity. They are not related to each other right now, but in the application logic, the not related. If there is an inconsistency, then it is filtered out and then later deleted. So yeah, this is the data, this is the domain, this is the sensor server that this is just the simple methods and interfaces and data classes that I use to communicate with the sensor server. And yeah, this is pretty straightforward. Then there is the main function, which is the entry point of the server module. So Linux ARM64, it compiles to native code in the ARM64 platform, and all of this code is just compiling to native code. That's pretty great because Kotlin is the best language that there is, and the more platforms that Kotlin supports, the better it is. I'm creating a server, starting the server, then running the main loop of the app in a coroutine scope. And then when the loop exits, it closes the server and stops it. So this is the main loop, takes all the database interfaces and the sensor server and hacks them together into a script. So it displays a list of menu options, then listens for those menu options, and when a button is pressed, it detects which button is pressed and then executes the logic that was programmed for that button. Pretty straightforward stuff. Building and releasing it into for the Raspberry Pi was a challenge. I wrote down all the code and then it was not building because I had to link some crypt libraries or something because it's a native app. It needs linking and something. So yeah, I've actually honestly I forgot what things I had to do for this to compile down for the Raspberry Pi. At the end, this is the line that I added, so it all came to work. This is basically the path of the libgcc library, and it is the ARch 64-bit ARM 64-bit GCC library compiler and GCC compiler. And this if I don't add this, then when I compile the server, it will not know what to do because it doesn't have the GCC for ARM 64. So yeah, so I had to give this explicitly, otherwise all the builds fail. And yeah, that's pretty much it for the server. And then coming to the client app. The client app uses Compose multi-platform. It's available for JVM and Android. And with Compose multi-platform, the main logic of my apps of the client app is written here. I have a simple data store to save the URL save the local URL of the server temporarily, so you don't have to put it again and again. Then it is structured like a typical MVI app, model view intent app, and yeah, it's pretty basic. As I showed you in the demo, the app is pretty much that is. And if you want to enroll the biometric details of a student, you can do that within the app. If you want to import a list of students, then you need to have a JSON file with the same schema, and then you can import with the JSON file pretty easily. So these features I implemented for the client app. And as I explained earlier, the desktop app and the Android app modules, they just import the client app UI and build the app. So that's pretty much it for the technical part of this app. The things that I got to learn while building this, a lot of things about Linux, a lot of things about how IoT devices work, how networking works, and it basically tested everything that I knew about uh, Linux and IoT and CI/CD. I have two CI/CD jobs to build the server binary and the Android app for this project in GitHub, and they work pretty much flawlessly. Yeah, so it was basically a test and amalgamation of everything that I like. Yeah, that is IoT, Linux, Raspberry Pis, and Android development, and mobile development, and desktop app development, everything inside the same project. And I think this is pretty much a good demonstration of all the skills that I have currently, and I'm very proud of this product.